Hi, welcome to YouWillUnderstandMath.com. Today you will understand the relationship between the geometric and algebraic representations of the limit. Here's the geometric representation or definition of the limit. Here's the algebraic representation or definition of the limit. They're very similar. The only difference is in the geometric definition, we use open interval notation. Here the puncture interval because we're excluding the value c. And over here, we're showing absolute value notation. If we can show that the open interval notation is equivalent to the absolute value notation for x as well as f of x, then we'll see that these definitions are equivalent. And that's exactly what I plan to do in this video. Here we will focus on the inputs, the x values, and the punctured open interval, c minus delta to c plus delta, excluding c. In inequality notation, we have x between c minus delta and c, or x is between c and c plus delta. Taking a look at the absolute value notation over here, we'll look at the right side where the distance between x minus c is less than delta first, and then we'll have a look at what it means for the distance between x minus c to be greater than 0. This is exactly the same as x minus c being between negative delta and positive delta, but not equal to delta, of course. What we can do is we can add c to each part of this inequality. We'll add c to negative delta, we'll add c to x minus c, and we'll add c to delta. And we get c minus delta. Negative delta plus c is the same as c minus delta, less than, these c's cancel out, we have x less than c plus delta. This almost looks like what we have over here. The only difference is that here we have a broken interval because we were being careful not to include c. Well, as I said before, now we need to consider the left-hand side of this inequality where we have 0 less than the absolute value of x minus c. What does this mean? Well, we know that this is the distance between x and c, and it's greater than 0. That means that the distance between x minus c can never be equal 0, and of course it can't be negative because it's an absolute value. Well, that gives us that x does not equal c, where x is between c minus delta and c plus delta, and the fact that we know that x does not equal c gives us exactly this expression here where x is between c minus delta and c, or x is between c and c plus delta. We can write this in punctured interval notation just as it is over here, so that this expression where x is in this punctured open interval is equivalent to this expression where the absolute value of x minus c is between 0 and delta. Now let's have a look at the outputs, the f of x values as far as interval notation and absolute value notation. According to interval notation, when f of x is in the interval from L minus epsilon to L plus epsilon, that means that f of x is between L minus epsilon and L plus epsilon. According to the definition of absolute value, anytime we have the absolute value of something less than a number, that is exactly the same as this f of x minus L being between the negative version of this number and the positive version of this number, as follows. Adding L to each side of the inequality, as well as to f of x minus L, we have L minus epsilon is less than f of x. These L's cancel out, is less than L plus epsilon, which is what we expected. We conclude that the geometric representation and definition of the limit is exactly the same as the algebraic definition of the limit. Thank you for watching this video. Please like and/or subscribe.